Hi everyone, I'm Ants Maria. So today let's talk about geometry. So I hope you all have heard about geometry. You have learned the chapters coordinate geometry and all. So what do you mean by geometry? Geometry, that is geometry. So can you give, if you can't define, can you give some examples of geometry? The geometrical figures that you have seen or you can see now also, like the corner, the lines, the window panes having the shape of a rectangle or a square or a circle, the roofs of home having a shape of a triangle, pyramid, like that. So around us we can see lots of geometrical shapes. So today in this class we will be seeing what is geometry, how is it significant to us, and we will also see who is Euclid and what is Euclidean geometry. Okay, let's see. Now, so geometry. So mathematically, when we look at geometry, when we say geometry, we can define it to be a branch of mathematics. So this is a branch of mathematics that deals with the measurement, the properties, the relationships of points, lines, angles, surface and solids. So geometry is nothing but a branch of mathematics that deals with the measurement, properties, relationships between of points, lines, angles, surfaces, solids, etc. So that is, geometry is all about shapes and their properties. That's the sum total of what you have seen. Now, the word geometry is derived from two Greek words, geo and metry. Geo and metry. Geo means earth and metry means to measure. So geometry is derived from the words geo and metrin, which means earth and to measure. So can you tell me how it came, how we coined the term geometry? Geometry arose from the need of people to measure the land. So we can see the examples of from our ancient history also. We can see from 3000 BC we could see the traces of geometry in our ancient history also. In nations like Egypt, Incas, Greece, they all have ancient geometrical traces in their history. So let's see how geometry was developed as a branch of mathematics. Okay, geometry has appeared to be originated from the need for measuring land. So can you see this? Yes, these are, you can definitely identify the place. These are the pics from Egypt. You can see the pyramids, the pyramidian shapes, everything you can see. And you can also see that they have been existing for a long time. So those people might have known how to construct all those things. So to construct these structures like a pyramid and all, they need lots of calculation. They need to know so many geometrical formulas, so many geometrical constructions. So let's see how the geometry originated. Now, this is the river Nile. So there is a story behind how revolutionary developed this much. So how the need for geometry made us to realize that we need some formulas, we need some constructions, we need all those things. So actually the river Nile floods every year. We have seen flooding in our places also. Nearly in Hyderabad there was a flooding, right? So this river floods every year. It happened to be flooding every year. So annually this floods. Then what happens? See, the crop fields, the lands, everywhere it will be flooded. So then after the flood, people won't be able to recognize their lands. They will start quarreling like anything, for like saying that this is my land, and you have encroached in my area, like that. So then there arises the need to measure the land, to construct boundaries, to construct bridges, like that it happened. So that dire need of them led to the discovery of so many geometrical shapes, geometrical formulas, so many things, and that's how we can see. In India also, in the case of Mohenjo-daro excavations, we can see that in our Indus Valley civilization, we have used so many constructions, like all the houses were properly constructed, there were lots of rooms, there were proper drainage system, the roads were parallel. So in all this we can see that from ancient times we were using geometry every day, without actually saying this is mathematics, this is geometry, like that, but we were actually doing that. We are practically using that. Okay. Now, this is Euclid. So, then we have seen that the people used this geometry practically. So then a teacher of mathematics, Euclid, in Australia of Egypt, collected all the known work and arranged it in his famous treatise, his book Elements. So he arranged it in his book Elements. He divided this book into 13 parts, and each chapter is called a book. So due to, he also contributed in his book, so much of contributions from him, and he even collected from his ancestors all the ancestral knowledge, everything he collected, and then he compiled this book. He is called the father of geometry. So Euclid is called the father of geometry. Now, can you identify what are these? Yeah, these are nothing but geometrical shapes. So, can you identify which one is a solid? Yes, you are correct. This section are solids. Now, why do you say they are solids? So, you can see they are having a 3D shape. You already know what is 3D. You have seen 3D movies, right? So, 3-dimensional. Now, let us see what do you mean by dimensions and all. Dimension means that we need, it defines the points required, or the measurements which are required to define a thing. So, okay, let us see that later. A solid has shape, size, position, and can be moved from one place to another. So, clearly we can see this is also a solid. It has shape, it has size, it has position, it can be moved from one place to another. So, solids are things like that. Now, it has boundaries are called surfaces, and they are said to have no thickness. Now, in geometry we will be considering solids 3D figures, something like this. So, in here its boundaries are called surfaces. We can see they are surfaces, and surfaces are said to have no thickness. So, maybe it is a little difficult for you to identify, but let us see, take the example of this cuboid. So, we have a cuboid here, and this is the cuboid, this is a solid, and then we have the surface of a cuboid is a rectangle. So, we have a rectangle here. Now, let us see, the boundaries of the surfaces are curves of straight lines, boundaries of, so if we have taken a sphere, its boundaries are curves, spheres, it's curved thing. So, here we have taken a cuboid, so here we are having a straight line as its boundary of the surface. Now, the lines ends in points, see, the lines will end in point. So, we have seen a cuboid, then its boundaries are surfaces, its boundaries, the surface of the boundaries of the surface are curves, and the endpoints of lines are points. Now, dimensions. Consider the three steps from solid to point, that is solid, remember the cuboid. Then, here we have the cuboid, then we have its boundary as surface, then it have its boundary a line, and then the line ends in a point. So this the steps, 3 steps. Now in each step we lose one extension. So and that is called a dimension. Dimension, see, in the cuboid you had length, breadth and height. Oh sorry, length, breadth and height. So in the cuboid you had all these things. There is length, there is breadth and there is height. So 3 things. That's why this is called a 3-dimension. Now in a rectangle, what is happening? There is only the length and the breadth. So 2. So it is having a dimension 2. And in a line, so a point is enough to describe a line. So if you have a point, see, you can see this, no, the pointer. So this is a point, and if we trace the point, we will get a line. So a line is having 1 dimension, only 1 dimension. Then what about point? Points are having no dimensions, because see, to see that we are representing a point to be like this, but actually we cannot do that. So a point is not having any dimension. Okay. The number of dimensions is how many values that are needed to locate points on a shape. So to represent a point, we don't need anything, so any value. So a point is not having a dimension. Now to represent a line, we need 1 point, one small little point we need to represent a line. Now to represent a rectangle, a surface, you need 2 points, 2 coordinates, like you saw in coordinate geometry, x and y. You saw that, right? So when you try to take a point there, you are getting the coordinates x and y. So there are 2 coordinates. So in a rectangle you need 2 things to define a rectangle, that is its length and breadth. Now in a cube or a cuboid, you need its length, breadth and height. So let's see. Now Euclid, as I told you, Euclid collected all the ancestral knowledge about geometry. He also contributed into that, and then there were some things which cannot be proved, which we cannot prove through any method, giving example or no, we can't prove that, but it is true. So he assumed such properties, and then he classified them into axioms and postulates. So axioms and postulates are assumptions that are actually obvious universal truth. Okay. Now axioms and postulates. He used the term postulate especially to geometry, to those assumptions that are relating to geometry. So those assumptions that are relating to geometry are called postulates, and axioms that can be in general. So yeah, a common notion often called axiom, on the other hand, were assumptions used throughout mathematics and not specifically linked to geometry. After Euclid stated his postulates, he used them to prove some other results. Then using these results, he proved some other results. The statements that are proved, so proved statements are called propositions. They can all be also called as theorems. So proved statements, or the statements which we can prove using some or the other method, they are called propositions or theorems. We use these axioms and postulates to prove these theorems. Okay. So theorems or propositions are statements which are proved using definitions, axioms, previously used statements and on. Okay. So let's look at some of Euclid's postulates. So we'll see 5 postulates. So in that, first postulate, can you read this? A straight line may be drawn from any one point to any other point. Okay. A straight line may be drawn from any one point to any other point. So suppose I am having a point here. So I want to draw a line. So through this point. So this is a line. So this was the point. So this was the point. So a straight line may be drawn from any one point to any other point. So if I have 2 points, can I draw a line through these 2 points? I can draw, right? So this postulate is obvious, very obvious, and we cannot prove this. So if you have two points, you can draw a line through them. Then, so can you try to draw another line through these points? So you have these 2 points, this is A and this is B. So we have a line through this. Can you try to draw one more line through this A and B? So if you try to draw a line through, if you try to draw a line through A, it will be like this, but it doesn't go through B. So if you try to draw a line through B like this, it doesn't go through A. So can we say that there is only one line which can be drawn when 2 points are given? Try this and see. So given 2 distinct points, there is a unique line passing through them. So if you are given any 2 points, so there will be only one line that can pass through any 2 points. If they are given any 2 points, there will be only one line that can pass through that. Even if you try to draw in any other way, there won't be any line which can pass through any other way. If you have a 1 point, you can draw so many lines through that in however way, infinitely many lines can be drawn. But if you are given 2 points, only one line can pass through them. So a unique line will pass through them. This is axiom 1. This is from the postulate we got another axiom. A straight line may be drawn from any one point to any other point, and to indicate that it is going on. It is never ending, never stopping. So terminating means stopping. Okay. So a terminated line can be considered as a line segment. So as you know, a line segment has 2 ends. A line segment is nothing but a portion of line that has 2 end points. So a line is something which is having no length, it is always straight, no width, not length, no width, it is always straight, and it is extending in both directions. So that is a line. So a line segment is a part of line which is a part of line having 2 end points. So the postulate states that a terminated line can be produced indefinitely. So that is, the postulate states that if you are having a line segment, it can be extended indefinitely. So do you think this is true? Can this be true? Can you imagine that? So let me show you. Okay, now we are having a line segment. Okay, now I am going to make it into a line. We have to see, now it becomes a line. So when I extend the line segment, it becomes a line. That means it can be extended indefinitely on both the sides. So if you are given a line segment, you can extend it. You can extend it like this. You can draw dotted lines and you can extend it in both sides. So that's what our theorem as postulates states. See, it becomes a line, it becomes a line segment becoming a line. So let's see. So if you are given a line segment like this, you can always extend it like this in both directions. So that is, a line segment can be produced indefinitely. Nice. Now postulate 3. a circle can be drawn with any center and any radius. So can you draw a circle? Let me give. Okay, the center should be 0, 0 if you are taking a graph sheet, and the radius should be 5 centimeter. Okay, center should be 0, 0. So this is my center, 0, 0 the points. So this is the graph line, and 5 centimeter is my radius. So this is 5 centimeter, then my circle will be like this. So if I say any center and any radius, if I take like 10 centimeter, this can be drawn, like 10 centimeter will be here. So we can draw again a circle there. Sorry, my lens may not be that proper. So a circle can be drawn with any center and any radius. So you can try drawing a circle of radius 7 centimeter. Can you draw that? Yes. No. Yeah. Now, this is a question we have to solve. Prove that an equilateral triangle can be constructed on any line segment. So, the things that we know are postulate 1, 2 and 3. And now we have to prove that an equilateral triangle can be constructed on any given line segment. So, equilateral triangle, what do you mean by an equilateral triangle? A triangle with all the sides of same measure. If all the sides are same, then it is equilateral. Then also all the angles will also be same. So, we have to construct an equilateral triangle on a given line segment. So, if you are given a line segment of 5 centimeter, you have to draw an equilateral triangle of 5 centimeters. So, how can we prove that? So, can you remember which postulate can be used here? Yeah, we only saw a postulate on line segment, that is the second one, which is that a terminated line can be produced indefinitely. Yes? Okay, let's try to see that if we can use that. Okay. Let me open it. 1 second. I'll just show you. Okay. So we have to see that, and then okay. Now, so let's draw a line. Take a line of, okay, let's take a 5 centimeter line segment. So you have drawn a 5 centimeter line. Use a pencil and a scale. Okay. Draw the line. Then using a compass, take the measurements and draw a circle at the point A. So at this point you have to take that point as center and measure the length of the line segment and then draw a circle like this. So like this. I hope you are following that. So similarly, take this point as the center and this as the radius and draw again a circle. So you will get full circles, not like this arcs, you will get full circles. Then note the point they are meeting. Mark the point and join the line segment using a scale and a pencil. So now we got a triangle. Can you measure the sides, the length of the sides? It will also be 5 centimeters. So why do you think we got it to be 5 centimeters? Because this line we took for drawing this circle, we took the lines, the radius as this line segment. So the radius will be this in 5 centimeter only. Similarly, to draw this circle, we took the center this and the radius this, the same. So this line segment and this line segment, see, both will be equal to the radii of the circle. Hence, they will also all be same. Hence, all the sides are same. Equal means they became an equilateral triangle. Okay. Now, let's check what all things we saw it in today. So, blank. Fill in the blanks. First one. Blank are statements which are proved using definitions, axioms and previously proved statements. What do you think? Yes, it is theorems or propositions. Second one, straight true or false. Axioms are obvious universal truth. Is it true? True. Then postulates can be proved. Postulates should be proved. Okay, sorry, it's a mistake. Postulates should be proved. The statement is postulates should be proved. Is it true? It's false. Postulates, there is no need to prove a postulate. It's obviously true. Then the next question. To illustrate the postulate, a line segment can be produced indefinitely. Two students draw the following diagrams. Which of this is a true statement? Okay. First student draw the line segment like this. The line segment can be produced indefinitely. Second one like this. Now, the statements are only student 1 is correct, only student 2 is correct, both students are correct, neither student is correct. So, which one will be the correct answer? B, because a line segment can be produced indefinitely means that it should be produced in both sides, right? So, this is the correct figure. Okay, this is your home assignment. First one, state true or false. There are infinite number of lines which pass through two distinct points. Is that true? Second one, a terminated line can be produced indefinitely on both sides. Is that true? And the third one, if two